Hey friends, Mrs. Derby here. Time for lesson 9 in Unit 6. I have my workbook handy, I have a couple pens and pencils, and I also have my student packet or any copy of the unit circle that you have available to you. A couple things that I've noted up here that we're going to use today, and not sure if you've noted these already in the past, but good to make sure we're all on the same page. I see throughout the unit circle a couple points that are square root 3 over 2 and square root 2 over 2. And I know somewhere along the way I put this equivalent just to kind of get an idea of what those are. When I look at my calculator in radian mode, doing something like the sine of pi over 6 gets us to that exact value for 1/2. Oops, sorry, just hitting the focus there. And then cosine of pi over 6 gives me that 0.866. I think we've looked before already about why it's square root 3 over 2. That idea that we were doing, finding it was 3/4 and then square rooting it. And the same thing kind of goes for this square root 2 over 2. But it's just nice to have this equivalency for our square root 3 over 2 is approximately 0.866. Square root 2 over 2 is approximately 0.707. Good numbers to have as we start looking at today's lesson. What we're going to look at today is now connecting sine and cosine with our trig functions, the ones that we were just talking about in lesson 8, about them being periodic, right? So if we have these sine and cosine values, always remembering that cosine is our x value, sine is the y value for each one of these ordered pairs, these coordinate points. We're going to now see how cosine and sine change as we move around the unit circle. And we're going to actually discover that they are periodic functions. They repeat over and over again. We'll see why. So, starting with section 9.1. If there's a point P on the unit circle at 1, 0, we want to describe how the x-coordinate of P changes as it rotates once counterclockwise around the circle. So we're still moving this way as we normally have. And when I think about the x-coordinate, it starts at 1. Here's our x-coordinate starting at 1. And then it gets shorter and shorter and shorter until it's up here at 0. Okay, remember we're just thinking about the x-coordinate. So as it moves around the circle, that x-coordinate gets a little bit shorter, and a little bit shorter, and a little bit shorter until it's at 0. So it gets smaller until at pi over 2, straight up on the unit circle, it is at 0, right? So it gets smaller as it's going from here to there. And then it gets even smaller because it's going negative. Remember, at this point here, it's going to wind up at -1, 0. So it keeps on getting, it goes negative until at pi, it is at a -1. Okay, so it gets to be a larger and larger negative number. Then as we continue around, we wind up back at an x value of 0. Right, so again, it's going to become larger. Remember that it's going from a negative number and coming back to 0. That means it's getting larger. So by 3 pi over 4, it gets larger and larger and larger until it's back to 0. And I almost didn't leave myself enough room here, because we need to take it all the way around that circle until we're right back to where we started at 1, 0. So by the end, it's going to keep on growing. This time it has now turned into positive values until it hits 1. So it starts at 1, goes to 0, goes to -1, back to 0, and up to +1. Hang with me, okay? Because we're actually going to stick right with that. We know that the x-coordinate is cosine. So I want to take this information right here, and we're actually going to also do section 9.2 at the same time. As long as we're using this info, let's stay focused on just cosine, okay? Just the x-coordinates. Notice for 9.2, it asks for each tick mark on the horizontal axis, plot the value of the cosine of that theta, that angle. Remember, cosine is our x-coordinate, where theta is the measure of an angle in radians. It goes once around the unit circle from 0 to 2 pi. And there's a class display, but you know, we've already got it right over here, and we're going to use our nifty student packet. So let's put what we have already figured out here from our warm-up. When our angle is 0 radians, it starts at 1. Let's put that point up there for cosine at 1. Then we said by pi over 2, it reaches 0. Here's pi over 2. At this point, it would be at 0. Then we said by pi, it's at -1. So I'm taking the cosine of pi, my output, cosine of pi, my output would be -1 down here. By the time I got to 3 pi over 4, we're back up at 0. Ooh, did I say 3 pi over 4? That can't be right. Absolutely not. Sorry about that. Down here we're at 3 pi over 2. Fix that with me. Sorry about that, friends. If you're not sure, double check me here. Little gaff. Fixed it though. Found it and fixed it. By 3 pi over 2, it was back at 0. And then by the time we got all the way around at 2 pi, all the way around the circle, it ended back up at 1. It may look like some straight lines, but if we start putting in some other values with it as well, in fact, using some values from our unit circle here, I'm going to keep on graphing some more points in between. At pi over 6, my x-coordinate is square root 3 over 2. Square root 3 over 2 is 0.866. So here at pi over 6, we're up here even above 0.75. And then at pi over 4, we're at 0.707. So pi over 4, we're here at just below that upper tick mark. Pi over 3, we're at 1/2. Pi over 3, here at 1/2. Ooh, and now maybe you're starting to see it's got a little bit more of a curve going on to it. I'm going to keep on putting these points on here. Just keep on following along with me. I'm just going to go all the way around the unit circle with some of these key points to get us going. All right. So 2 pi over 3 is at -1/2. 3 pi over 4 is at -0.707. 5 pi over 6 we're here at 0.866. Keep on going. 7 pi over 6. That same value. Remember, they're going to keep on showing up like that. Yeah, see, that was messing me up. That should be 5 pi over 6. Your book made a mistake this time. The scandal. Sorry. 5 pi over 4 Again, we're just kind of starting some of that mirror imaging that we've been seeing so far over and over again. 4 pi over 3, we're back up at 1/2. And so we could keep on putting in more and more of these points, but what we're going to see is this nifty wave when we connect the dots. A wave that starts up at +1, dips down to -1, and then ends up back at +1 where it started. And we could repeat this again and again if we just keep on going around the unit circle. All these values will start to repeat, and we'll have this cool wave going on. So our cosine wave has some key points. If it's just basic cosine theta, and I say that because in our upcoming lessons we're going to start moving this side to side, up and down. We're going to start stretching it taller and squishing it. Everything from Unit 5 is coming right back here. But we can also have some ideas about cosine. It starts at 1. I'm doing a terrible job writing words today. All right, starts at 1. X intercepts at pi over 2 and 3 pi over 2. Dips down to -1 and ends back up at 1. I'm going to change colors. Love my color coordinated ideas. Keeps me in check. Cosine starts at 1, x-intercepts, ends back at 1. Going back to our warm-up here at 9.1, this time we're going to think about the y-coordinate, and the y-coordinate is the sine of the angle. So our y-coordinates start this time at 0. By the time it gets up to the top, it has grown to 1. All right, so these points, as we move up here, this y value has gotten much, much taller. Right? So it gets bigger until it hits 1. Then it gets shorter again until we're back at 0. So by the time we've reached pi, we're back at 0. 3 pi over 2, we've gone down to, so we've gone negative now. Goes negative until we're at 3 pi over 2, at which point it is at a -1. So then here it stays negative. And by the time we get back to 2 pi, we're right back to where we started at 0. So, right next door, probably not much of a surprise to you, this time we're going to graph this sine function using those same kinds of values. So we're going to plot these same kind of points and keep on moving. I'm just going to knock this out of the park. Do it along with me or work at your own pace. Starts at 0. I always get my main points in first because we should have these cardinal coordinates pretty well set by the time it's at pi over 2. It has gotten bigger to 1. By the time we're back at pi, it's at 0. 3 pi over 2, it's at -1. 2 pi, back to 0. And again, we can put in lots of these points in between. This time though, remember we're looking at the y-coordinate. So by pi over 4, we're at 0.707. Pi over 4, we're still at 707. Remember, those are those ones that are reflecting right across. Pi over 6, we're at half. 5 pi over 6, we're also at half. You're probably seeing a new pattern developing. And so what we have here is a graph that looks kind of the same, a wave that's going on there, but it has a different kind of look to it. Right? A couple differences going on here. When we have our sine theta, our basic parent function, it starts at 0, rises to 1, x-intercept at pi and 2 pi and 3 pi and 4 pi. Okay, these x-intercepts up here were at pi over 2, 3 pi over 2. Oh, patterns everywhere, right? 5 pi over 2, 7 pi over 2. Every half pi up here. Down here, it's every whole number of pi's going on. And starts to repeat itself again and again. So we can start to spot our cosine and our sine functions pretty nicely. Kind of cool going on. What do you notice about the two graphs? Lots of things that we could notice. We can notice that one of them starts at 1 and the other one starts at 0. We notice about they both range from -1 to +1. They do a full period in one full rotation, 2 pi, right? So very different. We also can start seeing some other things, like if we kept this going the other direction, and we'll see this in an upcoming lesson too, that we can also continue this other guy in a backwards using some negative angles. We'll see what that might mean in an upcoming lesson. But it's going to be reflective over the y-axis. It is an even function to pull us back to Unit 5, whereas if our sine function kept going in a negative manner, it would be rotational. This would have rotational symmetry. So there's lots of things that we could actually notice about these two graphs, but some nice things that they have in common. Okay, so any angle measure between 0 and 2 pi does give a point on the graph. We are not just locked in to these nifty points here on our unit circle. There are all kinds of coordinates in between there. So the fact that it's a continuous circle, the fact that we're working with this continuous circle means we can have any angle measure between 0 and 2 pi. So I could pick a point on this graph right here if I wanted to, and as long as I could figure out or estimate what that angle would be, I can find a point that matches. Pretty cool to see these graphs going on, and it's pretty awesome when you start seeing them on your graphing calculator too. If you are using your graphing calculator, first of all, make sure that you are in radian mode, and a y equals, we can start doing things like the sine of, sorry about that, let's try that again, the sine of x, that would put us there. Now remember, this is our same thing, that it's x and it's theta, all that good stuff. And now I'm going to go to my zoom feature, and I see number 7 is zoom trig. We're doing trigonometry here. Sine, cosine, and tangent is all kinds of trigonometry. And there we go. There is our sine function matching up with our sine function right down here. Starts at the origin, goes up to 1, bounces down to -1, and keeps on repeating.